Hello everyone, welcome back to this ARIMA Models and Box-Jenkins model selection tutorial in Stata. My name is Juan and today I'm going to be completing this series with the video number 3, which is Diagnostic and Forecasting. For those of you who are watching this video for the first time, I want to let you know there's a video number 1 and number 2 where we have identified the appropriate models for the Consumer Price Index of the USA, and then we have estimated those models in the video number 2. Now it's time to check for the diagnostic and forecasting. As I just mentioned, stage number 3 is diagnostic and forecasting. We have our potential candidate model, which we have determined this in our video number 2, and is the ARIMA 211. So you are wondering, now what should we do with this model? Well, we have to verify that it satisfies the requirements for a stable univariate process. So what we have to confirm in this stage is that the residuals of the model are white noise. We're going to do that based on the portmanteau test, where the null hypothesis is that the residuals are white noise. If this is satisfied, we will proceed to check if the estimated ARMA process is covariance stationary, that is, that the roots should lie inside the unit circle. Finally, we will check if the estimated ARMA process is invertible, that is, that all the MA roots should lie inside the unit circle. If these conditions are satisfied, you can forecast with this model because it satisfies all the requirements for the stable univariate process. However, if it doesn't satisfy these requirements, you will need to repeat the selection and estimation method again and try with another potential candidate. In Stata, the first thing that you have to do is to ensure that the last model that Stata has recorded is the ARIMA 211, which is the correct model. So I'm going to type ARIMA CPI and ARIMA 211. I'm going to type enter. So now we ensure that Stata has on record the correct model. So now recall that we have to confirm that the residuals are white noise. So for that purpose, the first thing we need to do is to generate or predict our error series. So I'm going to type predict error, comma, and then resid. So what this is going to do is generate the errors of the model. So you can see that Stata has generated the series and has recorded it in here. So now the next thing that I would like to do is take a look at this graph and ensure that it's going to wiggle around the mean. Okay, so I'm going to type summarize error. So you can see that here has provided us with some statistics. We have the mean, the standard deviation, and we can see that the mean is around the 0, so that's good. I'm going to copy this value because I would like to include it in the graph, the mean. Now to generate the graph, I'm going to type tsline error, that's the name of our series, of our variable. And now I'm going to type white line, so that's what you're going to do. You're going to paste in here the value of the mean. So I'm going to type, hit enter. And you can see that Stata has produced the graph. You can see that all these values wiggle consistently around the mean, around this 0.003. So that's really good. This is red line is the red line that we have asked Stata to produce using this command in here. And the only value that looks kind of critical, which makes sense, is the value around the, if you can see, the end of 2008, beginning 2009. So that's the period of the crisis. That's why this value looks a bit more critical than the rest, but everything looks good for these residuals. They will consistently around the mean. So all I need to do now is to confirm with the portmanteau test that my residuals are white noise. So I'm going to type wn test, then q, and then error. That's the command to produce the portmanteau test. So you can see here Stata has produced this portmanteau test, and here we have the p-value, which is 0.9235. Recall that the null hypothesis of this test is that my residuals are white noise. Because this value is bigger than 0.05, I cannot recheck my null hypothesis. Consequently, we can confirm with this test that my residuals are white noise. I'm going to go back now to the slides just to show you what was the last step, and then we're going to execute that in the Stata. So this step is done. We have confirmed that the results are white noise. So the last step would be to check that the estimated ARMA process is covariance stationary. This is that the R roots should lie inside the unit circle. and also that the MA roots should lie inside the unit circle. In Stata, to produce the roots graph, I'm going to type stat and then roots. I hit enter, and you can see that Stata has produced this graph. Here the title says inverse roots of the ARMA polynomials, and we can see that the blue dot is for the R roots. Recall that we had two AR components, the AR1 and AR2, and then we have an MA component. We can see that these three roots are lying inside the circle. So that's a good sign. So this confirms that my residuals are white noise and that the process is stable. In Stata, to forecast our ARIMA model, the first thing that we need to do is to include more observations. Recall that we are working with the Consumer Price Index for the USA, and we have observations until February 2021. I would like to forecast the remainder of the year, so what I need to do then is to type in command is ts append, comma, add, and in parentheses I'm going to type 10, which is 10 more months, and I'm going to enter, and now I'm going to show you what Stata did. I'm going to type browse in the command, enter. You see that we have observations starting from the year 2008, first month. I'm going to scroll down, and here you're going to see that Stata now has added 10 more months of observations. Okay, you see we have until December now of 2021. Of course, these values are not here because we don't have them. We have to forecast these values, and in order to forecast, what I'm going to do then is going to type the following command, is predict. Then I'm going to just name FCPI, which would be the forecasted CPI. Then Y dynamic, and open parentheses. I'm gonna type M, and then the year, which in this case is going to be 2021 M3. I'm gonna explain to you now what this line is. So we want to predict the forecasted. This is the name of the variable that is going to generate in here. This is the forecasted CPI. And we're telling that it's monthly data that it has to forecast. And I want to start forecasting from the month 3 of 2021 because that's from the observation that we don't have. So it's going to then forecast starting 2021 month 3. I'm going to type enter. So Stata has generated the missing values. And the next thing that I would like to do is just to label this variable. If you see here, this label is kind of long. When we are going to produce our graph, it's going to mention this name, which I don't like that label. So all we have to do is just type the following command, label variable. Then I want to change the variable of my FCPI variable, which that's the name of, if you see here, that's the name of our variable, FCPI. And I'm going to put forecasted CPI. And that's all. You hit enter. We have changed the label. You see now it says forecasted CPI in here. And all that is left is to make the graph. I would like to plot both the CPI and my forecasted CPI. I hit enter. And you can see now that Stata has produced the graph. In blue, we have the original data, is CPI USA. We know that it goes until the year 2021, February. And then in red, we will have the forecasted CPI. These are the values for the remainder of the year. Now, as well, if you type browse, it's going to show our data. And if we scroll down, you're going to see now that Stata has generated the forecasted values for the remainder of the year. So that's going to be all for today. I hope you found this video useful, and I would like to invite you to subscribe to my channel if you would like to get more content related to applied time series forecasting, and all of these topics are going to be focused on economics. I would like to thank you for watching this video, and have a nice day.